All right, we've talked about translations. We've talked about reflections. Let's talk about rotations. So rotations are also an isometry, right? That if you're spinning around a certain point, that kind of guarantees you're not really changing much about the shape, but you will be changing its orientation. So a couple of vocab words that we need to know. Whatever point we're rotating around, we'll call the center of rotation. We are only going to rotate around the origin just to keep things simple, but you can rotate around any point. And then you'll choose, of course, an angle of rotation that you want to rotate at. So if we're going to rotate and map every point to a prime point, so P to P prime, Q to Q prime, R to R prime, that type of stuff, one of the following things needs to be true if it's a rotation. So here we have in this particular example Q. If Q is not the center of rotation P, then QP equals Q prime P. And the measure of angle P, QP, Q prime is x degrees. Or if Q is the center of rotation P, then the image of Q is Q. Meaning, if you're already if you're on the rotation, then it's not going to be, if you're on the center of rotation and you rotate, similar to if you're on the line of reflection and you reflect, nothing happens to you. And for everything else, that basically, if you were to treat the center of rotation as the vertex, then creating the angle from the prime point and the original point, and then the vertex being the center of rotation, should be the degree in which you rotated. So this is how we would actually use like kind of our protractors to do this. So you could rotate off of anybody. First, you need to draw a line from your point to whatever your center of rotation is. We're only going to do the origin, but this is to show that you could do it off of anything. Whatever that measurement is, you're going to need to repeat it. You're going to want to repeat it at whatever angle measure you're rotating. And that's obviously going to, probably take a while. So could we do this? Sure. But it's kind of it would just take so long that I wouldn't make you do this very often. I wouldn't give this as a test problem. It'd take you probably several minutes, seems a little unfair. But we'll do some activities in class with this, which is fun. This is what I want us to be able to do. Rotate about the origin. Okay, rotate about the origin. So we're actually going to break it down into like predictable rules for a 90 degree, 180, and 270 degree rotation. Why not 360? I'd love for you to pause this video and really think about that. Why not 360? Hopefully you didn't pause long and you went, well, 360 is like a full spin, so I don't really, at that point, we're in the same place. Exactly. 90, 180, 270, try to think of it as really like basically, are you moving into just one new section? Are you moving 1, 2, 1, 2, 3 in terms of the quadrants on a coordinate plane? So here we have it. If you're going 90 degrees, then the only thing that's happening is you invert the points, so it's BA, and it's the opposite of B. Literally, look at this example. Here's AB. I rotate it 90 degrees. Kind of makes sense. Right? We're going to invert it, and it would make sense that now from here to here, my X values are now opposite of what they once were. Here I am in the positive, positive, then I'm moving to negative, positive. When I rotate 180 degrees, right, I'm now at the same, like I'm not inverted anymore. It's AB, but they're both opposites, right? Makes sense. So from positive, positive to negative, negative, and then B, negative A. So it's inverted to BA, and now this time it's the Y value that's the opposite. So pause, write these rules down. This is the big stuff. And we're going to jump right into just practicing this, right? It's tough to memorize these rules, which is why I'm not going to make you, right? I'm going to have us use a reference sheet so that we don't mess this up. So when we see here, okay, 90 degrees counterclockwise, you'll be able to go 90 degrees, 90 degrees. What is that? Oh, yeah. Switch A and B and make B a negative. Switch A and B, make B a negative. So for every x, y that I have, it'll become negative y, x. So if this v right here is, what is this? Negative 5, 3. Then the opposite of that would be, we're going to do negative 3, negative 5. Negative 1, 2, 3. There's my v prime. My u prime is here at negative 1, 1. So flip it around so it's 1, negative 1, and do the opposite y. So that's negative 1, negative 1. There's my u prime. My t is at negative 1, 0. So now it's going to be 0, negative 1. And then lastly, negative 5, negative 1 will become 1, negative 5. And that looks pretty good. Looks like a great little 90-degree rotation that we just did there. So don't worry about memorizing this stuff because I'm not going to make you do it. Just be prepared to use the information from this video, and then hopefully that's in your notebook, to solve problems. And then last thing we need to do is we can talk about dilations, but that's easy, and then putting it all together.